Okay, so we have a company that's making stuff and selling that stuff at a certain price, and it costs them a certain amount to make the stuff, and they want to know how much stuff they should make to maximize their profits. So here's all the pieces we have. P of X, the demand function they call it, is what's on your price tag, or the price that you can get for the things you're selling. You multiply that by the number of things, in this, which is X here, to get your revenue. So revenue, the money you bring in, is going to be X times 5.5 minus 0.012x. I'm going to multiply that x through, and I'm going to fix the order of this thing as I'm doing it. So the revenue is minus 0.012x squared plus 5.5x. So that's how much money comes in. The cost function is the money that goes out, and you don't have to put an x on that when it's already built in. And again, I'm going to fix the order of this. I don't know why they feel like putting these backwards. Just trying to provoke me. 0.0003x cubed minus 0.02x squared plus 1.5x plus 90. Okay, so revenue is the money coming in, costs are the money going out. Your profit overall is your revenue minus your costs. So the entire revenue function minus the entire cost function. Minus 0.012x squared plus 5.5x. I'm subtracting all of these, so minus 0.0003x cubed plus 0.02x squared minus 1.5x and minus 90. I can collect like terms and put this in order just to get it looking as nice as possible. Overall, our profit function has a cubic term. There's an x squared and another x squared. We can combine those and get 0.008, I believe. 0.008x squared. And then we have 5.5x minus 1.5x is 4x. And the only constant term is the 90. So that's our profit. It would be minus 90 if x were 0, then it will increase for a while because of the linear term here in the x squared, but eventually this x cubed is going to take off. Even though it's got a very small coefficient, eventually this will take over because it has the highest power, and it'll drive the profits back down. So in other words, we expect the profits to start low, rise for a while, and then drop off again. And somewhere in the middle is a sweet spot we're trying to find where the marginal profit is exactly 0. That means if you're here, adding one more item won't increase or decrease your profits because you're right at the peak. But if you keep going in either direction, profits will start to fall off. So to find that, if we're looking for a marginal profit, we do the derivative of this, dp dx. I think in the workbook solution, they take these two derivatives first and then do revenue minus cost. I combined these first, and then I'm doing the derivative, which is going to amount to the same thing, as you'll see in a second. So our marginal profit is 3 times this minus 0.0009 x squared, and then 2 times this, so plus 0.016x, and here we just get 4. And we want all of that to equal 0. When the marginal profit is 0, it means you're right at the peak. There was a rising section, there was a falling section, so this is where the marginal profit's positive. Here it's negative. Right at the top is 0. It's like when you throw something upwards and it stops for just an instant before it starts falling back down. At that point, you'd say the velocity is zero. Here we say marginal profit is zero. And can we solve that? It's a quadratic, so we should be able to. Um, because these numbers are horrible, I'm going to multiply this whole thing by 10,000 and get minus 9x squared plus 160x plus 40,000. I think that'll be nicer to work with. I hope anyway. And so the quadratic formula tells us that our x values are minus b plus or minus root b squared minus 4ac all over 2a. And what does that give us? 160 squared minus 4 times 9 times 40,000 square root. So we get minus 160 plus or minus 1210.6 all over minus 18. If we do negative 160 plus, we get negative 160 plus 1210.6, and divide that by negative 18, and we get a negative answer, which I don't even know how to make sense out of. You can't produce negative 58 of something. That's the cubic playing tricks. I think down here there must be a place where the cubic function turns back on itself, but because you can't produce minus 58 of anything, I'd say that is a solution to be rejected. And if we use the negative out of here, if we do negative 160 minus 1210.6, and then divide that by negative 18, we get 76.14. And I don't know if you can produce 0.14 of a batch of this. I think I would be tempted to round this and just tell the company that their best bet is to produce 76 batches of whatever their product is. At that point, they'll be bringing in maximum money. If they go any lower, then they're missing out on some sales, losing money. If they go any higher, then their costs start getting high, and that starts hurting them so much that producing the more items isn't worth it anymore. So 76 is just the right place to be.